In some scenarios, there is the dual need for a system to perform radar operations while sending data to another cooperative system. For example, nodes in a surveillance multiple input, multiple output radar network. Airborne radar and ground-based station, vehicles in an intelligent transportation system. Possible solutions include the use of a secondary communication system with overheads in terms of resources allocation. An alternative is to switch between radar and communication operations with the drawback that the radar operation is not continuous. The last and most challenging solution is to embed data in the radar waveform, allowing both resources sharing and continuous radar operation. The radar team in the Sense of Signal Processing and Security Laboratories in the Center for Signal and Image Processing at the University of Strathclyde has developed a novel concept that enables joint radar and communication operations. The demo shows a communicating radar and a communication receiver in operation with a human target in the scene. The communicating radar embeds information data in the waveforms and then performs range and Doppler processing on the received echoes from the target. The output of the Doppler processing is shown in a spectrogram demonstrating the capability of the communicating radar to detect positive Doppler shifts when the target approaches the radar and negative Doppler shifts when the target moves away from it. Additionally, the microdoppler modulation due to the swinging arms and legs of the target are visible in the spectrogram. The communication receiver processes the received waveform and extracts the information bits transmitted by the communicating radar. In this case, the picture of Lena was transmitted successfully between the two systems. This technology will allow reduced production costs, weight, power, and the frequency requirements of systems requiring both sensing and information sharing. For example, autonomous airborne platforms will benefit from the reduction on weight and power consumption, extending the flight time. Furthermore, it is environmental friendly as it reduces the electromagnetic footprint of the overall system. The key aspect of the developed concept is the use of the Fractional Fourier Transform tool to generate frequency-modulated subcarriers carrying the information data while preserving the radar performance. Sets of information bits are modulated using standard modulation schemes such as QPSK, and then the Fractional Fourier Transform is applied to generate orthogonal subcarriers with different orientations in the time-frequency plane. On the radar side, the traditional radar processing is not changed, while on the communication side, the only overhead is the inversion of the Fractional Fourier Transform modulation for each subcarrier.